Now, all this kind of begs the question, really, why do we care about path-independent or conservative vector fields? Other than the mathematics is kind of cool, but why do we actually care? Well, there's several reasons. As an example, many vector fields that are actually found in nature such as gravitational fields, electrical fields of bodies at rest, that sort of a thing, are actually path independent. So we care about path independent fields because a lot of the stuff we work with in nature are path independent. Now, the fact that a gravitational field is path independent really means that the work done by gravity when an object moves really depends on its starting and ending points only, and not the path taken. Now, think about this for a second. Suppose that you toss on a 60-pound backpack, and you're gonna go. Here's ground level, and you're gonna end up going up here to the top of a building somewhere. This is where you're gonna end up at. You're starting down here. So here you are going up these stairs, back and forth, back and forth, back and forth, back and forth, going up the zigzag stairs, to eventually you reach the top, and there you are. Now, how much work was done by gravity? Well, if I jump in here to an elevator and go straight up to the top, and then here I am, what this means is because the gravitational field's independent, the amount of work done by gravity is not different, or it's not dependent upon the path. So the work done here, if I call this work 1 by gravity and this work 2 by gravity, then work 1 equals work 2. Now that's extremely important because when a vector field is path independent, we can define the idea of potential energy we can define this idea of potential energy of a body when a body changes position. The potential energy is actually equal to the amount of work done by the vector field, which again will only depend on its initial and ending point, not the path taken. So the potential energy of the 60-pound backpack doesn't matter how I got up to the top of this building. The potential energy that it has is the same. If these paths were not path independent, or if the field was not path independent, then the whole concept of potential energy would be absolutely horribly complicated, because it would be meaningless without knowing the actual path traveled. So that would suggest that if I'm standing here and I have a 60-pound backpack and I'm getting ready to toss it over the side, that the potential energy of this backpack would in fact depend on how it got up there, not the mere fact that it's there. So if you just think about that for a minute, I mean, that you wrap your mind around that, and it kind of makes sense that, wow, gravitational fields really must be conservative to begin with. But this is just a couple of ideas, a couple of reasons why we actually care about path independent or conservative vector fields. The main thing here is really that they show up an awful lot in nature, and obviously the science mathematics is the language of nature, and it's how we communicate with nature, how we figure out what the heck's going on out there.